Okay, this is our solve aloud, and I may not do all the math, but I'm going to think my way through this, and I'd like you to pay attention to this. So we have 4 problems here from Stoichiometry homework number 1, and we went over this in class already. This is just my mind in the back of your head trying to reinforce those good habits. So the first thing we always want to do is we want to read through our problem, and we want to label our given, and we also want to label where we're going. And so if I read through this real quickly, I can see that I'm starting out with 125 grams of potassium chlorate. And what I'm concerned about finding are how many moles of oxygen are going to be produced. Now, after I balance my chemical equation, which is balanced here already, what I want to make sure of is that I don't get confused about potassium chloride. So I'm just going to cross it off because I don't need it anymore. Now, in this particular problem, we're going from grams to moles. So therefore, I'm going to need to have 1 mole ratio in my stoichiometric problem, and I'm going to need to have 1 conversion factor beyond that that's going to convert from grams to moles so that I can utilize that mole ratio. So in order to get started, I'm going to always state my given, and it's 125 grams of potassium chlorate. And so I immediately write that down, number, unit, substance. Now, despite the fact that I know that I need to have a mole ratio, I'm going to hold off on that. I can't use a mole ratio until I have moles in the numerator of my preceding number. And since there are no moles here, I'm going to put grams of potassium chlorate on the bottom. What I'm doing here then is I'm using my conversion factor to convert from grams to moles right here. And then after this, what I can do is I can go ahead and I can bridge from moles of potassium chlorate in my mole ratio, and I can go ahead and go to moles of oxygen. Okay, so notice that where I'm going is on top of this conversion factor. I'm going from potassium chlorate to oxygen. So potassium chlorate is on the bottom of my conversion factor, oxygen is at the top. Now, the numbers that I fill in here, I'm always going to put 1 next to moles when I have a gram to mole or a mole to gram conversion factor. In that conversion factor, then, I'm going to put the molar mass of that substance. I will always have the same substance on the bottom and the top of a mole to gram or a gram to mole conversion. Over here, however, this is where the coefficients come in. I'm using the 2 in front of the potassium chlorate and the 3 in front of oxygen, and I'm going to plug it in right here. Okay, now in this particular problem, please note, grams of potassium chlorate cancels, moles of potassium chlorate cancel, and I'm left with moles of O2, which is what I set out to figure out. Now, if you're in my classes, I also have you box these up so you don't get confused. So do what you want to do. Now, when you find the answer here, please remember that you're multiplying all of your numerators and then you're dividing by your denominators. Don't enter stuff into your computer and then round it and re-enter it and clear it out and so forth and so on. It's going to be 125 times 1 times 3 divided by 122.6 divided by 2. When you do that, your answer is going to be in 3 significant figures, and you can check that on the answer document online. Okay. The next problem is hydrogen peroxide decomposing into water and oxygen gas. And you've seen this in class. We've done a demonstration on this with the catalyst, manganese dioxide. Now, you read through and you figure out what it is you're starting with. And right here, we're starting at 10.0 moles of hydrogen peroxide, and we're going to figure out the mass of oxygen that gets produced. So we don't need this anymore, no more water after we've balanced. Here is my given, here's where I'm going. Hydrogen peroxide to oxygen gas. Now, I have a mole to gram conversion here. So I'm going to start out with my given 10.0 moles of H2O2. That's hydrogen peroxide, stuff in your medicine cabinet. Now, in this particular problem, I'm starting with moles. So I can just go right ahead, since I have moles right here in the numerator of the number before, I can go ahead and I can immediately plug in my bridge. And what I'll be doing is I'm going from H2O2, or hydrogen peroxide, 2 oxygen. So I'm going to put moles of oxygen on top of my conversion factor. Please note that this is where I put in my coefficients. I have 2 moles of hydrogen peroxide form 1 mole of oxygen gas. Now, I don't want moles in my answer, so this is where I'm going to plug in my mole to gram conversion for oxygen. Okay, so I have O2 on the bottom, I have O2 on the top. Once again, my gram to mole or my mole to gram conversions are always going to have the same substance, but my mole ratio has different substances. This is my bridge, this is just a mole to gram conversion. So I have 1 mole of oxygen, and that means I'm going to have 32.0 grams of oxygen. And in case you're wondering, 16 is doubled because I have O2 here. Now, this math is easy because it's 10 times 32, which is 320, divided by 2, which is 160. I have to make sure I show 3 significant figures, so I'm going to have 160 decimal point grams of oxygen gas that are formed. Okay, now the next problem, problem number 3. I'm taking octane. Octane is my hydrocarbon. It's right here. And I have 2.50 moles of octane. It's right up above, moles of octane. There we go. And I want to know how many moles of carbon dioxide are formed. So I'm going to put my question mark grams right here. These guys are only good for balancing purposes. I don't want to get confused, so I'm going to cross them off. I'm going to box up my other things, I'm going to mark up my paper, show that I'm thinking. So, whoops, I put grams here. What did I mean to put, class? I needed to put moles here. Caught myself. All right, so I have moles of CO2 I'm trying to find. Now, I start out with 2.50 moles of C8H20. And this is a mole to mole conversion. I like this kind because they're real easy. I don't even need a periodic table except for writing my chemical formulas. I need no gram to mole or mole to gram conversions. All I have to do here is plug in a mole ratio which bridges me from octane over to carbon dioxide. So I have octane up here. On the bottom of my mole ratio, then I'm going to put moles of octane. And on the top, I'm going to put moles of CO2. And what do I put in front of here? Maybe I better put these coefficients. For every 1 mole of octane that is combusted or burned, I'm going to have 8 moles of carbon dioxide. So we have a lot of carbon dioxide gas that's released into our atmosphere as a result of this combustion. Now, moles of octane will cancel moles of octane, and I'll be left with moles of CO2. So, 2.50 times 8 is 20, I believe, and so this would be 20.0 moles of CO2 formed. And that's all there is to it. Make sure that your units are canceling. And this is a unit-driven system, so it shouldn't be too confusing once you get the knack of this. My very last problem here is about rocket fuel, and this is hydrazine right here. I have 775 grams of hydrazine, and I want to know how many grams of dinitrogen tetroxide with mass of N2O4 is going to react with this hydrazine in order for this reaction to go to completion. Now it looks like I left out a coefficient here. My goodness. I wonder what will happen if I put a 2 in here. I think I have to have a 2 right there. I don't know what happened to that. So that'll give me 4 nitrogen here plus 2 is 6. 6 here. That'll give me 8 hydrogens and 8 hydrogens and 4 oxygens and 4 oxygens. Okay, sorry about that, crowd. So once I have all that balanced, I can go ahead and cross off what I don't need anymore. So in this case, I have a gram to gram conversion, and that means I need 1 mole ratio and 2 other conversion factors. The first one will be grams to moles to get me to my mole ratio. And then after that, I'm going to have a mole to gram so that I can get to grams of dinitrogen tetroxide. So I'm going to start out with my 775 grams of N2H4. After that then, remember I can't plug in my mole ratio until I convert my grams of N2H4 into moles of N2H4. And I have to use my average atomic masses from the periodic table. So I have 2 nitrogens at 14 apiece, that's 28, plus 4 is 32. So I've got 32 grams of hydrazine for every 1 mole of hydrazine. 32 grams of hydrazine. I'll try to make that a little bit better. I know it's just sloppy, but it's the best I can do. To 1 mole of hydrazine. Now, I have to plug in my mole ratio. My mole ratio is going to take me from moles of hydrazine. I'm going to get rid of that, and I'm going to bridge to dinitrogen tetroxide right here. So I'm going to have moles of N2O4 on the top. And I look at these coefficients. I have a 2 in front of hydrazine. I've got a 1 in front of dinitrogen tetroxide. Now, I don't want moles, I want grams. So I have one more conversion factor, and that's going to be moles of N2O4 on the bottom. And on the top, it's going to be grams of N2O4. So now I have to add to get my molar mass. I have 4 times 16, which gives me 64, plus 2 nitrogens is 28. That'll give me 92.0 grams for every 1 mole of dinitrogen tetroxide. Remember, only 1 mole, grams per mole. And over here, grams per mole. In my mole ratio, I can put other numbers besides ones, because those are from the coefficients in my chemical equations. Now, look at the cancellation. Grams of nitrazine cancel, moles of hydrazine cancel, moles of dinitrogen tetroxide cancel, and I'm left with grams of dinitrogen tetroxide. So I'm not going to do the math here. It should be in 3 significant figures when I'm done. I think from class it ends up being this many grams of dinitrogen tetroxide in 3 significant figures. I think it starts out as 1,114. In order to get that, 775 times 1 times 1 times 92 divided by 32 divided by this denominator here, which is a 2, and of course divided by this denominator here, which is a 1. Okay, so hopefully if you missed class, or if you just need to hear my lovely voice, you've had a little bit of a chance to think more about this than in our 22-minute class periods. Okay, I'll post the other one tomorrow. Thanks for listening, and I'll see you in school tomorrow. Bye.